Welcome to the Reimagine Mobility podcast series here from ADL. I'm here, my old colleague Vivek. I'm back in our days. Thanks for joining me, Vivek. Maybe to start out with, before we really jump into how we reimagine mobility with what you guys at Apex are doing, where you're working at today, give me a little bit of a background so that our listener understand where you're coming from, what your background is, what the company you're working for right now is doing. And then after that, let's jump into it.
Great. Thank you so much, Stefan. Yeah, it's my honor to be talking to you guys today regarding mobility. I'll give you a brief background of myself. So I'm an engineer by training. Started my career building simulations and for testing of brake systems and steering systems at Delphi in the early 90s. I got really intrigued with the possibility of making cars handle extreme situations like slippery roads and high-speed turns safely and elegantly with the help of embedded software. So that really put myself on a trajectory to designing and writing embedded software for the early ABS and traction control systems for GM vehicles in the 90s. And that was a really exciting time. This was we were doing this quite early with very primitive tools and methods back then. And then I moved to ETAS, which is a division of Bosch. And at the time, the software complexity was already going through the roof in terms of available microcontroller capability back then. And ETAS was sort of a pioneer in industrializing the art of automating the creation of high-quality embedded software through tools and methods that were developed at Bosch. So I had the opportunity to bring these tools and methods to all the big OEMs in the US, Europe, and South America as the industry was adopting more embedded software and better technology in these vehicles. And what attracted me the most was the opportunity to work with some of the brightest people in the industry over 2 decades and watch the automotive industry evolve from being purely mechanical, as you guys know very well, to becoming more mechatronic, where the role of the software was increasingly becoming more and more important. And that has only accelerated in the last 15 years or so, as we all know. So after ETAS, I joined AVL, where I had the unique opportunity to launch some of the most advanced simulation and testing tools for the next generation technologies that were coming on, like driver assistance systems and driverless cars. And during that time, electrification of the automotive industry was also gaining momentum. And I saw firsthand the new electric vehicle manufacturers, how they were building vehicles, which was quite different from the way the established OEMs were doing it. And then had an opportunity to work for a small startup, which was building driverless technology, both hardware and software, for public transit vehicles, like small 6 to 8 passenger low-speed shuttles and up to 25 passenger vans. So this is where I saw firsthand how many cities, campuses, communities were experimenting with the idea of adopting driverless technology to address some of their needs in cities, especially around safety and especially during COVID, when it was becoming more difficult to have people move around in a congested environment. So during this time, I also realized that for these types of vehicles to become successful, you need a very robust regulatory environment as well as acceptance by the public. So safety was becoming a top concern for everyone. And at this time, in the middle of the last year, 2022, I got the opportunity to lead the Apex.AI business development activities in the US. So that's where I am today. And I realized that the automotive industry was changing rapidly again from being hardware-centric to becoming more software-centric. And for anybody who has seen the evolution of electronics in the cars, has probably seen, for example, the dashboard displays becoming more flexible and user configurable, the displays screens becoming, bringing in new navigation and entertainment options, for example. But it's also frustrating that once you buy a vehicle, it is practically already old because it's fixed in its capabilities for the time that you own it, which could be 10 to 12 years. So people are demanding that these vehicles can be updated with the latest safety, convenience, and personalization features throughout the life cycle of the vehicle, just like your smartphone. And companies are responding to that trend. But that requires that the underlying software and hardware architecture of these vehicles be drastically changed. So this is where Apex.AI comes in, which is where I work today. So we provide the underlying software development kit, commonly known as the middleware, that essentially abstracts the underlying hardware, which is the compute from companies like Intel, Qualcomm, or NVIDIA, and the real-time operating system, just like QNX or Linux, and allows you to build modern applications on top. So we have a couple of products like Apex Grace and Apex IDA that are built on open standards, such as ROS, which is short for the Robot Operating System, which has been developed specifically for robotic applications by a large community of developers. The Eclipse Isorix, which is a communication mechanism used to transport data on a single chip, and Eclipse Cyclone DDS, which is a communication mechanism used to transport data across a network such as Ethernet. So we are basing our products based on these standards, but we are sort of industrializing them so they can be used for the safety relevant applications like automotive mobility. We are the only company that brings the power of open standards to the automotive industry with a safe, certified, and developer-friendly software solution for the mobility. So that's where we are today.
Okay, good.
Yeah.
So when I listen to all this, the two themes here are safety and software, right? So with your history and your passion, as you mentioned earlier, when you were at General Motors and then at Bosch, AVL, it's heavily software related and it's heavily safety related. So in this discussion here, when we reimagine mobility, what's the next step? I mean, everybody today talks about safety. At the same time, we're putting more and more autonomous features on the road that, depending on which vehicles you drive, I travel a lot and use a lot of different vehicles when I get to the place, rental vehicles that I try to always have a different one, and I always obviously use the ADAS feature, and sometimes I have to say, wow, great job. In other cases, oh my, this really scares me myself a little bit.
Yeah.
So where do you see the industry going? It's clear software is becoming more and more dominant. You can never forget physical, mechanical, and electronics, obviously, because otherwise software is not going to do anything. It's just going to be thin air, so to speak.
Yeah.
But where is the software and majority speaking also the safety going from here? What do you see in the next 5 years, Vivek?
Yeah, so I see three major trends, right? One is we are all seeing a lot of electrification happening in the automotive industry and across all mobility applications, not just automotive. Even off-road vehicles and luggage handling vehicles getting electrified, which is a push to make things cleaner, more sustainable long term. I'm a true believer in that. I myself have an electric vehicle and also solar panels, so make sure we are charging them more sustainably, right? And I think that's going to be the trend. That gives an opportunity for vehicle manufacturers to sort of design their hardware and software from the ground up, which means they can build more software-defined architectures than the legacy vehicles. So you can see a lot of the new electric vehicle OEMs actually producing products at a much faster clip in terms of revisions, updates, because they have modern architectures. And that's going to be the trend. I think also with legacy or traditional OEMs, they are going to re-architect their next generation vehicles in those terms. What I see is in the next 5 to 7 years, there's going to be a transition. For now, I think most vehicles that you buy today have very little software updatable content. There is some in there. There are some companies who are able to do updates in real time. Most of them are not at the moment. I think by 27, 28 timeframe, you will see more of those vehicles being updated remotely, features being fixed and new features being provided. And by 2030 approximately, I think you will see that becoming more mainstream. So in the next few years, there'll be a transition. There'll be more adoption of different architectures, underlying architectures in hardware and software. And it'll be driven by electrification, but also be driven by safety and automation. And the reason I say that is, safety and automation are areas that can be very heavily influenced by software. Safety in the sense, the human beings being responsible currently for driving vehicles have a certain response time, and software can definitely, with high fidelity sensors, you can have software respond 10 times faster than humans, and that's especially critical in urban areas, like in cities. Like, I'm in a small city like Ann Arbor, but even here, when you go downtown, I feel sometimes that some of the large vehicles that we see it plying on the road in urban traffic can benefit from much better safety features, especially for vulnerable road users like pedestrians or cyclists. So to make roads safer, you need better sensing capability, better reaction times from those vehicles, and that's possible through software. So from my perspective, urban safety is going to become more and more important. Yes, highway safety is also important, but I think a lot of lives lost today are in the urban environment, and we can reduce that by not only software in the vehicles, but also there are other infrastructural issues we have, which we will not talk about today, but software definitely has a key role to play there in the vehicles. So you can improve safety, you can improve sustainability with electrification, and then automation. I think with automation, what we will see in the next 5 to 7 years is increased adoption of automation in areas where there is repetitive tasks, there is drudgery due to repetitive tasks, like in industrialized environments, warehouses, luggage handling, things like that. Those will be automated first. Then we will see as automation becomes more accepted on public roads, I think you will see a bit more adoption of automation on public roads as well, with proper guardrails around it in terms of what can be done and what cannot be done. So automation, in my mind, has a much longer arc at the moment in terms of adoption. Electrification will come first, urban safety, and then finally automation. That's how I see it.
Okay, no, it's good. It's perfect. Yeah. Let's dive a little bit into the software, right? I mean, fundamentally, I always look at software. You have the low-level software, what you mentioned before, that interfaces directly with the chip, right? And you have the middleware that you guys are working on. And then you have what I would say what the customer can touch or at least feel and or see to some degree, which is the application layer, right? And those, also when you talk to a software guy, a whole lot more. But yeah, these three layers, when we look at this, right, we have a lot of companies that talk about software and they really mean application layer. We have more and more companies that are talking about the importance of the middle layer. I would say there's few that really talk about the base layer software, as I call it, right? But this is certainly the critical piece to make things work. But when you look at it, when we look at the future, and you mentioned it, the software-defined vehicle, right? Mm-hmm. Depending if it's for an electric vehicle, if it's for a vehicle specifically rated to ADAS or level 4, maybe level 5 in the future software, what is the most important layer of the software and why from your perspective?
Yeah, so I think the best analogy here is our mobile device, right? So you can see on a mobile device, you get an underlying piece of hardware that you purchase, but obviously in there you have an operating system that you don't see, but it's there. It makes things happen. It is sort of the network behind everything else, and then you have the apps on top, right? The apps are the ones that you download based on your needs, and you personalize the device to your needs based on that. So something similar is happening in the automotive industry. The only challenge today is there is a variety of operating systems in place, and there's a variety of hardwares. technologies, hardware architectures in place, which is all good. And on top of that, we have additional requirements for safety. So yeah, a mobile device can be rebooted if it freezes, but a car has to have a safe operating system, has to be robust, and you can't afford to reboot it every day or every second hour because of a problem. So there's strict safety requirements for mobility applications. So what we are trying to do at Apex.AI is making that middle layer, which is in between the top level applications that make your life convenient on the road, and the underlying hardware and the base level software. The base level software is provided by companies like BlackBerry QNX, Green Hills, and others. That's the real-time operating system. And on top of that is a communication layer that essentially allows this large amounts of data coming from different sensors to be transported across the chip architecture to be sent to the sensors, or from the sensors to the actuators. And then on top of that is this framework that we provide called Apex Grace, which essentially abstracts all the lower levels, so the application layer software can be written without much concern about what's underneath. And that's what we see in the Android ecosystem, for example. So you have multiple hardware providers for the Android phones, but a common operating system and framework sitting on top. And then you have personalization by the OEMs on top in terms of the look and feel of the Android device. So Apex.AI's goal is to sort of become the standard framework for automotive applications going forward, following that particular model. And that will make it much easier for app developers for your convenience features like your seat, your rear view mirror, all the other applications that you will have in the vehicle will be common across different platforms, but they'll be personalized according to the OEM preference. So OEMs can differentiate their vehicles based on the applications, regardless of the underlying hardware and operating system being used based on the Apex middleware. That's the idea. So we are trying to make sure that we have that robust safety certified middleware framework available, which companies can rely on, and they can build their applications on top to differentiate.
Okay. So as we again here together reimagine mobility, what are the 2 or 3 things, Vivek, that you and your company see in the market that you would say needs to change, right? And I'm talking maybe the supply base is not focused enough on the middleware that you just explained, and the ability that allows you to put software onto any hardware device independent of what the OS is, so to speak. Again, similar to the app, right? An app I can download on almost any platform because the software infrastructure is there. Or maybe, again, what do you guys see that you're saying, I wish I could change maybe the mindset of the OEMs to be more focused on A versus B? As it relates to, again, everything as it relates to software and safety. Let's keep that theme here from your history in the automotive space. But what do you see are the 2 or 3 things that if you could change today, you would change, right? A perspective, a direction, a focus. Share a little bit.
Sure. So what we see, I think this is a standard challenge in the automotive industry that we see today, is essentially adopting a modern vehicle architecture. And for the layperson, the meaning of architecture is essentially how information within the vehicle flows, right? It comes from sensors, like you have cameras and other sensors in the vehicle, and it goes to a certain central brain in the vehicle. Currently, there is no central brain in most vehicles, and so the brain is sort of distributed, and that has an impact on how data flows, how much latency is there, how information is secured in the vehicle, and has an impact on all of those. And then there's a patchwork of solutions to address each of those requirements. So that particular challenge is being addressed by taking a clean sheet approach. right? Having one central compute that everything comes in there so that you can harden it for security, you can make it robust, you can upgrade it in one go, for example. And then you have the software development challenge. Most of the current challenges around software are related to the way software is defined at a OEM and then developed at a tier one and then brought back into the OEM for integration, and then you find issues and bugs, and then you have to send it back to the tier one for fixing, and then you have a delay. So that introduces a lot of delay in the overall release of the vehicle. And then in service you find bugs, and then you have to go back and fix them, and then you have to get the vehicle back into the shop for a software update and things like that. So there are all these business and technology related challenges. The way we propose these can be solved is working tier ones and OEMs working more collaboratively on a single repository, for example. The way modern software is built outside of automotive today can be brought into the automotive industry. They're working collaboratively. They are reducing the development life cycle by taking the same approach in the prototype build as they would do in the production build. So today, prototypes are built on a specific platform using specific technologies. Then we go to production, you have safety certified software, which is different from the prototype world. Now you got to rebuild the entire application again, test it again. So we reduce that dramatically by using the ROS open standard. And we have sort of hardened it for production and for safety purposes for automotive. So you can do the prototyping, you can do the development all in one cycle. And you can see the newer OEMs are actually producing vehicles at a much faster clip, 2 or 3 year development timescales than the traditional OEMs because they have these processes in place. And we are sort of bringing these new technologies also to other OEMs who want to adopt them. So making the development more seamless, making in-production updates more seamless if you have the right architecture in place. And so keeping the entire vehicle life cycle in mind, optimizing all these different areas of the development cycle. So those are the challenges the industry faces, and that's how we are addressing them. Obviously, there's a lot of collaboration here that is key. We are not doing everything. We are only providing the middleware, but we are advising our customers on also the right approach to the architecture, a right approach to building modern C++ based software, how to do this in the cloud, how to integrate everything together so that you reduce the development cycle. That's what we are focused on.
Okay, very good.
Yeah.
So 2 more questions. The first, you brought it up, right? The startups are sort of having challenged and maybe shown the traditional guys, OEMs, on how you can get software done faster and how you can launch a vehicle faster, because software oftentimes now is the long lead item because it's taken over a much bigger portion of the vehicle function, control, or base, right?
Good.
At the same time, I'm hearing, people saying, yeah, that's great, but they don't understand automotive as well. There's a lot of, again, here's the word again, safety implications if you don't do the software right. We see some OEMs talking about bringing all software in-house. Certainly some US OEMs have started and are doing it. We see in Europe, there is one that has sort of founded their own group, which they're struggling with right now. What do you see? How do you answer the safety concern? And what do you see? Where is this going? Is it all going, everybody's going to bring it all in-house, or everybody's still using the traditional format of outsourcing and more this collaboration that you just mentioned? But tell me a little bit, what do you see from your perspective? Where does this go?
Yeah, so I think this has been an issue that we have sort of observed over the last 15, 20 years. The way it's also a little bit of a cultural difference. In Europe, most OEMs have been relying on tier ones to build their software systems, and they do integration in-house. In North America, I've seen OEMs build everything in-house, just buying the hardware and doing the entire software in-house. And that seems to be continuing in North America. And there are advantages to that also. And then now we see OEMs, as you said, building these small groups more agile technologies, modern software practices in small groups because, they have their own cultural, legacy to deal with in the traditional environment. So that cannot be changed overnight, but they want to absorb all the new methods in the newer groups. So what I imagine will happen is that these technologies, the new software development processes, will become mainstream within the OEMs as we talk about making the architectures more modern in the next 5 years. It has to come together. We can't have two different groups doing software. And when it comes together, I think the entire company will use a common software methodology. It has to happen. If you have two different methodologies, you will always have friction. You'll always have problems. So they will all come together. Whether they all do the entire software in-house or outsource some of it remains to be seen. I think there will be more collaboration, as I mentioned earlier, which means the core software will not be developed by the OEMs because there is no value for the OEM to build, for example, an Android OS. There's no value for a mobile OEM to build the Android OS. It comes from Google. It's standard. They maintain it. You take it and you build the entire ecosystem around it that gives value, that makes it looks like your phone. Same thing for all the OEMs. They will take a standard operating system, a standard hardware, and build the experience on top that makes it that particular OEM's vehicle. So that is the overall trend. I think both the OEMs across the world will eventually follow that trend. There will probably be 2 or 3 market-leading middleware platforms like Apex in the market, and they will choose which ones to use. They will all be equally performant in terms of data transport, communication, safety, security, and all those things. So people don't have to worry about the integrity of the middleware. The user experience will determine which ones are more prevalent. So in the end, the software developer's experience, the user experience is what matters the most.
Okay.
And that's where we think we will end up in a few years.
Okay, good. Final question for you.
Yeah.
What's going to be the next vehicle you buy and why?
So, good question. I mean, I currently have a Chevy Bolt EV, and I love it. And I will probably continue with the electric vehicle. I'm looking at the Bolt EUV right now, which I like a lot because the Bolt EV is not available anymore. But I'm a small car guy. I live in a small city, so I would prefer a small electric vehicle, which I can shuttle around 50 to 100 mile range in the city. I also have a standard ICE vehicle, which I use for long distance driving. So that's the whole thing about EV versus hybrid. I have a hybrid household, is what I say. I have an EV and I have an ICE, so I am a hybrid household. I use the ICE for long distance and the EV for my daily local driving.
That's good.
So I think the next one will be an EV. Which one, I don't know yet. I'll be up to replace my EV in the next 6 months, so I will make a decision then. Yep.
All right, very good. Thank you so much, Vivek, to help us here reimagine mobility from the perspective of what you have seen and what you're working in. It's been great. Thank you.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.